Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. Specifically, what we're going to be talking about in this video is how to implement packet filtering. We're going to be using IP tables to implement some basic packet filtering. We'll show you how. We're not going to talk about how to set up IP tables in general other than a few basic commands. We're going to just talk about how we can implement packet filtering. So what you'll need for this, if you are following along, you need to spin up a couple of Linux Academy lab servers, and we'll be using the local networks. Or if you have virtual machines, which we're doing here, then you'll need to have two virtual machines on the same network. I caution you anytime that you're using IP tables, as it's a firewall on a remote system, that you have some method of testing your changes before you simply apply them, because if you apply the wrong filter to the wrong section or the wrong policy, then you can lock yourself out of the system unless you're physically present. So we will be using, during this particular example, a couple of virtual machines on the same network to avoid having any inadvertent issues with remotely accessing our servers. So we have a CentOS 7 system that is running IP tables, and we can get a list of the rules that are currently installed on the system by doing an IP tables -L. And as it tells you, you need to be root, so let's do a sudo su to root and make sure that we are the root user. And once we're the root user, then we can do an IP tables -L. And we've got a number of different policies in place. Now, from a packet filtering perspective, if we want, we can change the default behavior of a particular policy simply by changing it with a -P. So for example, if we wanted to take the IP tables -L, let's grep for the forward policy. And we'll see that the chain forward policy by default will accept connections for the forwarding. What we want to do is we want to change that policy to default. The only time you can change a policy for an entire group is if it's been flushed of all of its rules. So in this case, forward doesn't have any other rules in it. So all we're going to do is an IP tables -P forward, and then we're going to change it to drop. And that will apply immediately the drop policy for the chain forward. And you'll see that that immediately changes the policy. But that doesn't do a lot of good, because now I have to go in and I need to add all of the rules for the chain, and then I'm going to just drop them all. So what I want to do here is I'm going to flush the IP tables rule set, just so that we get a clean bill of health here for all of the chains. So we've got everything is set to no rules in it, no IPs, and we'll change our forward back to accept. And then that way we can be sure that the forward is set back to accept. So right now we're not filtering anything. So what I want to do is I want to add a rule to the firewall so that I can filter out ping between the IP addresses in my client and server environment. And ping is an ICMP connection, so I'm going to define two different types of filtering policies that we're going to test out. So if we get the IP address of the server, which is 1.135, and we'll real quickly switch over to the client, we'll see that we should be able to do a ping on 192.168.1.135, and we get a response. And that's because right now I'm accepting and not dropping or filtering any of the IP addresses from my server. However, what I want to do is I want to add a policy that takes the input from the ICMP protocol on the interface that I've got here, which is EMP0S3, and I want to filter it out so that it drops. Now there's two types of policies that you may want to do from a server perspective for ping: dropping or rejecting. Now, if you reject a policy, if you reject a connection, you'll get an actual error message back on the client that says that it's not routable or that it's been rejected by the server. The problem with that is that it can, if you're trying to hide your server IP from the types of services that might be available on it or its existence in general, a rejection really confirms that they've got an IP address that's valid, whereas a drop just doesn't reply with anything. So let's start with the drop and then we'll change it to a reject and we'll see what the difference is. So if I do an IP tables, and remember I'm going to do a -A for add. For the input section, I need to tell it the protocol that I'm going to apply this policy to, ICMP --in -interface, and that's why we listed our IP here, because that way we need to say it's ENP0S3, so we're applying it to that interface, and then the type of policy that we're going to apply, which is drop. So now if I do an IP tables -L and grep for drop, I should see that drop ICMP from anywhere to anywhere. Now does that mean I can ping myself 192.168.1.135? I can. So let's go over to the client and let's rerun this ping. You'll see that from the server I can always ping myself because I've got localhost and the server is not leaving the interface. It's not going out the interface. It's going through its own network stack, so it's always going to ping itself. However, as you can see, I'm not getting any response back from the ping for my device here, and if I hit the Control-C, I'll see that 22 packets were transmitted and nothing was received back. Now that's important because at this point, I don't know that I was able to reach a valid IP address. However, if I clear this, and I want to say, let's do an IP tables --flush. And now what we're going to do is we're going to do an IP tables -A input --protocol ICMP -in -interface, and then it was EN0 ENP0S3, and then -J, and then what we're going to say is reject. Then what I should see, if I do an IP tables -L, and then grep for reject versus drop, because I flushed my tables, I'm going to say that reject with ICMP port unreachable. So now, although I can ping myself 192.168.1.135 on my own network, on my own network stack, if I go over to my client and I ping 1.135, now I get a port unreachable. However, because I get a destination port unreachable, the likelihood that I've reached the correct IP address from a security standpoint, I've probably exposed a little bit more than I intended. So generally, if you don't want someone to be able to communicate over a port, I recommend that you drop. You filter everything into a drop rather than respond. You really only want to respond on network ports that you want services to be listening on. And rejecting it, although can be useful from within a WAN, for example, or a multi-zone network inside a firewall, externally, I would recommend that you simply drop the traffic, because that drop will prevent anyone from knowing that that port and IP is even a valid port. So for implementing basic packet filtering with IP tables in Linux, that's all there is to it. My name is Terry for Linux Academy.